You know that moment of frustration when you've got this amazing AI, right? And you just want it to connect easily with all your tools, your data.
Uh,
But it feels like every single connection is a whole separate project. It's maddening.
oh, absolutely.
Yeah.
Like needing a different key for every single door in your house.
Hmm.
It's just not efficient.
Exactly. Well, what if it could be more like just plugging in a USB-C cable? One standard connection.
That's precisely the kind of thinking behind the Model Context Protocol, or MCP. That's the goal. That's simplicity.
Okay, MCP. So that's what we're diving into today. We want to get under the hood, understand what it is, how it works.
Why it's getting so much attention. Yeah. And we also need to talk about some pretty important security aspects, too.
Right, definitely security. We've looked at the official spec docs, a good introductory piece,
Yeah.
and even a research paper digging into the details.
Yeah, and the plan is to sort of boil all that down, give everyone a clear picture of MCP, the good, the challenges, without getting too lost in the weeds, you know?
Perfect. Cut through the technical jargon to what really matters for understanding where AI integrations might be heading.
Exactly what you need to know.
Okay, so let's start right at the beginning. In simple terms, what is the Model Context Protocol?
At its core, MCP is an open standard. Think of it like a shared rule book.
A rule book.
Yeah, a standard way for applications to give context,
Yeah.
relevant information to these large language models we're all using now.
So it helps the AI understand what it needs to work with other stuff.
Precisely. The big idea is seamless interaction, letting AI models talk easily to external tools, data sources, breaking down those silos.
Breaking down the silos. I like that. Better interoperability.
That's the key word. And, Anthropic started it for Claude.
Right? I heard that.
But it's crucial to understand it's open now. It's not just an Anthropic thing anymore. It's getting broader interest.
Okay, open standard. Good. And people can find the details where?
The official specs are up at modelcontextprotocol.io. All the nitty-gritty is there.
Great. So why this? Why MCP? Instead of just using the APIs we already have, we've been using APIs for ages.
That's the million-dollar question, isn't it? Think about traditional APIs. For every single tool, email, calendar, database, whatever, you need a separate integration, custom code, different documentation to read, different authentication methods, different ways things break.
Oh, man, yeah. And you have to maintain all of that separately.
Exactly. It's a huge overhead.
Yeah.
Now, contrast that with MCP. The promise is one standardized integration.
One integration to potentially rule them all.
Well, maybe not rule, but certainly connect them. An AI that speaks MCP could, in theory, talk to any tool that also speaks MCP.
Okay, so that single protocol versus dozens of APIs is a huge difference. What else?
Another big one is dynamic tool discovery. This is really interesting.
Dynamic discovery, meaning?
Meaning the AI could potentially find and use available tools without needing them explicitly programmed in beforehand.
Wait, really? So it could just learn about a new tool and start using it?
That's the potential, yeah. Think about AI becoming more adaptable, finding resources as needed. Big implications for autonomy.
Wow. Okay. That is powerful. And flexible.
It really is. And one more key thing. MCP supports two-way real-time communication. Think WebSockets, if you know that tech.
Like live chat, not just
Right.
request response.
Exactly. It's not just the AI asking for data and getting it back. It can also trigger actions in other systems and get instant updates.
Okay, give me an example. How would that look in practice?
Right. So imagine your AI assistant. It could check your calendar in real time, see you're busy, then maybe you ask it to reschedule a meeting. It could do that, and then automatically send email notifications.
All through that one MCP connection, not separate API calls for calendar, then email.
Potentially, yes. That's the streamlined interaction MCP aims for, much smoother than juggling different APIs for each step.
Okay, I'm starting to see the appeal. It sounds much more integrated. So how does it actually work? What's the architecture?
It uses a pretty standard client-server setup. You have MCP hosts.
Hosts, like the main application.
Yeah, the apps that need the data or tools. Claude Desktop is an example, or maybe an AI coding assistant in your IDE.
Got it. The thing doing the work.
Right. And inside these hosts, you have MCP clients. Each client talks directly, one-to-one, with an MCP server.
Okay, client talks to server. What do the servers do?
The servers are typically lightweight programs. They're the ones that actually expose the capabilities, the tools, the data resources, maybe some predefined prompts.
So they're the gateways to the outside world for the AI.
That's a great way to put it, gateways. They handle the connection between the AI host and whatever it needs access to.
And where does the actual data or functionality live? behind the server?
It can be in a couple of places. Servers can securely access local data sources files on your machine, local databases.
Okay, stuff nearby.
Right. Or they can connect to remote services, basically. The web APIs we already know out on the internet.
So the MCP server acts like a bridge or a coordinator. It figures out how to talk to the local files or the remote API.
Exactly. It's the coordinator, managing that flow of data and instructions, translating between the AI and the resources.
Okay, that makes sense. Client server, hosts needing stuff, servers providing it by connecting to local or remote resources. Let's dig a bit deeper now, the core components. What did the spec docs say?
Yeah, the docs break it down into layers. First up is the protocol layer.
Protocol layer. Sounds fundamental.
It is. It defines the rules of engagement, how messages are framed, how you link a request to its response, the basic patterns of talking back and forth.
The language they speak.
Precisely. And there are specific software classes mentioned, like protocol, client, server. You don't need the coding details, but they basically handle things like processing requests, sending notifications, managing the connection itself.
Okay, so that's what they're saying. How do the messages actually get sent? The transport layer.
You got it. The transport layer is about the how the messages physically travel. And it's flexible.
Flexible how?
Well, if the client and server are on the same machine, it can use something called STDO transport, just standard input-output streams, efficient for local communication.
Makes sense. Keep it simple locally. What about over a network?
For that, it typically uses HTTP, the web protocol, combined with server-sent events, or SSE.
SSE, right, for the server to push updates to the client.
Exactly. It allows that real-time flow from the server. The client usually sends messages back using standard HTTP POST requests.
Okay. And are the messages themselves standardized?
Yes, crucially. Regardless of transport STDO, HTTP SSE, everything uses JSON RPC 2.0 for the message format.
JSON RPC 2.0, so a consistent structure for requests and responses.
Absolutely vital. It ensures everyone understands the messages no matter how they arrived. Structured, predictable.
Okay. And what kinds of messages are flying back and forth in this JSON RPC format?
There are 4 main types defined by MCP. First, requests. Pretty obvious, you send a message expecting a reply.
Makes sense.
Then you have results. Those are the successful replies to the requests.
Okay. Request, successful result. What if it fails?
That's the third type, errors. Messages indicating a request couldn't be completed. MCP even uses standard JSON RPC error codes, like parse error if the message was garbled, or invalid request if it wasn't formed correctly.
Like a digital, I didn't understand that.
Something like that, yeah. And the final type is notifications. These are one-way messages, just sending info without expecting a response back.
Like an FYI.
Exactly. Just letting you know this happened.
Okay. Requests, results, errors, notifications. Clear. So how does a connection start and end the lifecycle?
Right. The connection lifecycle. It starts with initialization. The client sends an initialized request. Think of it as, hello, I'm here. I speak this version of MCP. Here are my capabilities.
Handshake.
Pretty much. The server responds saying, okay, I speak this version. Here are my capabilities. Then the client sends an initialized notification like, okay, we're good to go.
Got it. Introductions are made. Then what?
Then you're in the main message exchange phase. Just the normal back and forth. Requests, responses, notifications being sent as needed.
Standard operations.
And finally, termination. This can happen cleanly. Either side sends a close command, or it might just drop because of a network error or some other problem.
Okay, clear, start, middle, and end. Seems robust. Now, shifting gears slightly, what can these MCP servers actually do? The research paper talked about capabilities, right?
Yes, it did. It highlighted 3 main ones: tools, resources, and prompts.
Tools,
Yeah.
like actually doing things.
Exactly. Tools let the AI invoke external services or APIs, perform actions. And the paper noted this is different from maybe oldie function calling A being more autonomous, the AI selecting the tool based on context.
More context-aware selection.
Yeah, and they're designed to be modular, reusable,
Yeah.
build a tool once, potentially many AIs can use it via MCP.
Okay, that's powerful. Acting on the world. What about resources?
Resources are all about data access, letting the AI tap into structured data like databases or unstructured stuff like documents.
So giving the AI knowledge.
Pretty much. Think customer logs, document archives, letting the AI make decisions based on way more information than it has internally.
Like connecting it to a library.
Good analogy. And the third capability was prompts.
Prompts, like prompt engineering built in.
Sort of. Reusable templates or workflows managed by the server helps optimize AI responses Keep things consistent.
Ah, so for standardizing answers or tasks,
Right.
like a chatbot giving the same reply to common questions?
Exactly that. Or ensuring consistency if you're using AI for something like data annotation. Standard prompts help.
Tools, resources, prompts. Makes sense. Now,
Yes, it is.
security. The paper also talked about the server lifecycle and the risks involved there. That feels critical.
Absolutely critical. The paper breaks it into 3 phases: creation, operation, and update. And yeah, risks pop up in each.
Okay, let's take creation first. Setting up the server. What happens?
Key steps are server registration, giving it a name and identity.
Mm.
Then installer deployment, getting the actual software installed,
Right.
and code integrity verification, checking the code hasn't been messed with.
And the risks here. The paper mentions some specific ones.
It did. For registration, the big one is name collision.
Name collision, like two servers accidentally getting the same name. Or
Or worse, a malicious actor deliberately choosing a name very similar to a popular trusted server, trying to trick users or AIs into connecting to the wrong one.
impersonation. Classic. Okay, what about installer deployment?
Risk there is installer spoofing. Since there isn't always an official marketplace, people might use community tools, auto-installers,
Right, for convenient.
but those unofficial tools could potentially bundle malicious servers or compromise the installation process without you realizing. Convenience versus risk.
Yikes. And code integrity.
The risk is code injection or backdoors. Malicious code getting slipped into the server software, maybe through compromised dependency or during the build process. It could be hard to spot.
Okay, so creation has its pitfalls. What about when the server is actually running? The operation phase.
During operation, more risks. First, tool name conflicts. Similar to server name collision, but for the tools within the server.
So two tools called summarize.
Exactly. The AI might pick the wrong one, maybe a malicious one. The paper also warned about deceptive tool descriptions trying to trick the AI's selection process.
Like saying, this tool is safe and should be preferred.
Something like that. Then there's /command overlap. If multiple tools use the same command, like delete.
Oh, I can see that being bad. Delete could mean temporary files for one tool, critical data for another.
Precisely. Ambiguity leads to unintended, potentially harmful actions. And the third operational risk is sandbox escape.
Sandbox, the isolated environment tools run in.
Yeah. They should be isolated to limit damage if compromised. But attackers always look for ways to escape the sandbox and gain wider access to the system.
So the walls aren't always perfect. Okay, creation, operation. What about the update phase? Updating the server.
Updates are essential, but they have risks too. One is post-update privilege persistence,
Meaning?
meaning old, outdated permissions might stick around even after an update, and old keys still working on a new lock, basically. Unauthorized access could continue.
Not good. What else?
Redeployment of vulnerable versions.
Yeah.
Because the ecosystem is quite distributed, users might accidentally roll back to an old, insecure version or install an update from an untrusted source. There's no central enforcement yet.
Right, lack of a central authority on versions. And the last update risk.
Configuration drift. Over time, especially with remote servers, the actual settings can slowly change, drift away from the secure baseline, creating new weaknesses unintentionally.
Wow. Okay, that's a sobering list of security considerations across the whole life cycle. It's clear that security has to be baked in, not an afterthought.
Absolutely paramount. MCP offers power, but power needs careful handling.
So, with all that said, who's actually using MCP right now? What did the research say about the current landscape?
It's gaining traction in key areas. Major AI players like Anthropic, obviously, but also OpenAI.
OpenAI too. How are they using it?
They're integrating it into their agent SDK, planning it for their responses API, even the ChatGPT desktop app. It's about streamlining how their models connect to tools.
Big names validating it. What about developer tools?
Yeah, IDEs and platforms like Replit, Cursor, JetBrains are adopting it. Makes sense. Embedding AI help directly into the coding workflow is a big use case.
Helping developers code better, faster.
Exactly. And it's not just AI and dev tools. Cloud platforms are interested too. Cloudflare, Block, Stripe.
Cloudflare, what's their angle?
They're looking at things like remote MCP server hosting, moving it more into the cloud, which helps with scale and managing security, especially for businesses with many users.
Okay, so broad interest AI models, dev tools, cloud infrastructure. What about the actual servers? Is there like an MCP app store?
Not an official one from Anthropic, no. But the community has really jumped in.
Grassroots effort.
Totally. Platforms like MCP, Llama, Pulse MCP have popped up, hosting thousands of community-built servers.
Yeah.
And there are desktop tools, too, like Dockmaster Toolbase for managing local servers.
So a real ecosystem is forming even without a central market. Is it easy to build these servers? Are there tools?
It's getting easier. There are official SDKs, software development kits for popular languages, TypeScript, Python, Java, Kotlin, C#,
Okay, the basics are covered.
and the community has built more on top. Frameworks like Easy MCP, Fast MCP to speed things up, tools that auto-generate MCP servers from existing APIs, libraries for specific languages like Go, even hosting solutions and automation tools from companies like Mitlify, Speakeasy, Stainless.
Wow, the tooling sounds like it's maturing fast. That really helps adoption.
Definitely lowers the barrier to entry.
Can we look at some concrete examples? The paper mentioned OpenAI, Cursor, Cloudflare again in terms of specific use cases.
Sure, for OpenAI, as we touched on, it's about simplifying AI to tool communication. Using MCP and their agent SDK lets developers build agents that can use external tools more easily via MCP.
Making their AI more actionable.
Right. For Cursor, the code editor, it's about enhancing the developer experience. MCP lets their AI assistant interact with APIs, check code, modify files, all within the IDE. Boosts productivity.
Supercharging the coding environment.
Pretty much. And Cloudflare's use case is interesting because it's about hosting the MCP servers remotely, in the cloud.
Moving it off the local machine.
Yeah. That offers benefits for scalability, maybe easier management for businesses, and they're adding security like OAuth authentication for those cloud servers.
So different angles, making AI actionable, improving dev tools, providing scalable infrastructure. It really does sound like MCP is finding its footing.
It seems to be. It offers a really compelling answer to that messy integration problem we started with. A standard way for AI to talk to tools and data, it could unlock a lot.
A lot of potential for more dynamic, more context-aware AI.
Definitely. But, and it's a big, we keep coming back to.
The security challenges.
Exactly. All those risks we discussed, name collisions, code injections, sandbox escapes, vulnerable versions, configuration drift, they all need serious attention and solid solutions.
It's the flip side of the coin. More connection, more potential points of failure or attack.
It always is with powerful tech.
So wrapping up then, MCP looks like a key piece of the puzzle for how AI integrates more deeply into everything we do. It promises simplicity, flexibility.
But demands vigilance on security.
Right. So the final thought for our listeners, as AI gets woven deeper into our work and lives, protocols like MCP are going to be fundamental. What new possibilities, maybe exciting, maybe a bit scary, do you see opening up? And what risks might we be overlooking as AI gets these standardized ways to interact with the world?
That's the big question to ponder, isn't it? The potential is huge, but so is the need for careful, responsible development. It's worth checking out modelcontextprotocol.io, maybe exploring the community tools, just to stay informed on where this is all heading.
Definitely food for thought. Thanks for breaking that all down.
My pleasure. It's a fascinating space to watch.